Okay, this afternoon I'm going to talk to you about the hypergeometric distribution. So this is different from what we've done before in the sense this is non-symmetrical, or also might be known as non-uniform. So we're not having something that we had last lesson where everything goes along in a line. It's in fact, it's non-uniform. We can't get a pattern towards it. So this works for a finite population. And it's often associated with things such as quality control. So for example, you're making a set of brownies in the canteen, all of them need to weigh 21 grams. However, some of them don't. So that's the kind of question you ask, what is the chance I get something that isn't 21 grams? So there's a few conditions. It is discrete because there has to be either what we call a success or a failure. So that's the option. Now we make the number of successes what we know as little k. So you have, even though you have a finite population, which we'll call big N, we take a sample from that population and we call this little n. And they're the things that we need to be able to solve hypergeometric distribution. So we recognize it in a test because it might be talking about quality control or talking about two things, success or failure, and they're the only two options. So we have this big formula here, and how we actually put it into the calculator looks quite complex, but we use the CNR button. So if you get your calculator, this one here is where the CNR sits. It's just above the division sign. So CNR. Now these N and R don't correlate, but for example here, because if you think back to your combinations and permutations, this would be CKX. And here you'd have C big N little n. Okay, so K is the number of successes, X is what I'm testing, my theory that I'm testing, so how many am I testing that succeeded or failed, that kind of thing. But we're talking about in terms of success, but we have to discuss that in relation to a question. Okay, let's have a go using this big formula to work out. So 50 light switches, so that is our big N, being tested. We know the population is 50, but we know that 20% are known to be faulty. So this comes into our K. It isn't our whole K, but we use this to work out our K. So if 20% are faulty, how many would we expect to be faulty, I guess, in the whole population? So you put it down as 0.2, which is 20% as a decimal, times by 50. And if you get your calculator and you put in 0.2 times 50, what you get is 10. So 10 out of 50 are known to be faulty. That's quite concerning. If a sample of 8 switches, so this is my little n, is randomly selected and tested, what are the chances that 2 will be defective? So this becomes my X. So what you notice, we're talking about number of light switches all over. So 50 light switches, 10 light switches are known to be defective. N is 8 switches, and the chances that 2 light switches will be defective. So we're just working on a unit of light switches. Okay, let's try our formula. So what we get for our formula is, well, we have the K value, which is 10, and we write it out like this. We don't write it out the CNR, we write it out like this, but we put it into our calculator CNR. So we have 10 over X, well, we want to know if 2 are faulty, times by N minus K. So big N is 50 minus 10, and then little n, which is 8. 8 are being sampled, yep, that's right, minus I want to know if 2 are faulty, all divided by big N, which is 50 over 8 down the bottom. Okay, so I'm going to do the shadow in black, but the shadow is actually to show you how to put it into your calculator. So when I put it into my calculator, I put it in like this. So I go 10C2 times by, now what's your brackets? You're going to need brackets. Well, let's do 50 minus 10, which is 40. C6. I like to work these out first because I think it makes less mistake for my calculator to make a mistake. And I have to put brackets around all of this, divided by 50 C8. Now, pause the video for a moment and try and put it into your calculator and see if you get a similar answer. So when I put into my calculator, what I got out was 0.321724. So that is the probability that of any 2 that I choose out of the 8, that they will in fact be defective. So let's change it to a percentage, so approximately equal to, because it's not exactly equal to, 32.17%. Now I don't know about you, I probably would be choosing this company of light switches if I knew that was the chance that I will get two that were defective. So this is the next chapter of the textbook. You can go through and try it. This is an example of one of the harder questions. They do start a bit easier.